All right, let's take a look at your next lesson, which is the very last lesson before we get to inequalities, meaning less than or greater than symbols. And this is word problems with equations. Heading up to your learning goals in the document sorter, let's go ahead and take a look. And so now what we're going to do is we are looking at learning goal 32. I'll be able to define a variable, translate, and solve one or two step equations from a word problem that may include the distributive property. So we're still really doing 31 and 32 with this one, so we can label it as both. Okay. And so we have learning goal 31 and 32 are covered here, just because it's what we did in 31, but it includes word problems now. And this is similar to what we did in our last unit, except now you have an equal sign with it instead. But you've done word problems with expressions and distributive property. So we'll still be paying attention to, do you see any forms of repetition that might hint distributive and things like that. So let's go ahead and get started. There are a couple key concepts that you want to be aware of with any word problems. The biggest one is just read the problem. As you read it, notice important information, but really focus on what the question is asking you. That's going to help define your variable. And so that's where we're going to start off with today, is really identifying with each word problem, what is our variable going to be? And then we really want to focus on those keywords that are giving us hints to the operations, and then use a lot of just common sense and reasonableness as we go. So Cole's mom gave him a certain amount of money to buy a gift for his favorite teacher. Okay. Mr. Hodge. This covered 3/5 of the cost. So I'm noticing little things like of means multiply. That amount is what Cole gave him total, or Cole's mom gave him total. But I'm really going to focus on this question. How much did the present cost? And so that's my unknown. The thing I don't know, that's going to be my variable in this case. And so when you write variables, typically you want to use a variable that matches the word that you don't know. If it's anything related to cost and money, you're going to want to use C. Okay. Otherwise, you can be creative with other options, but that's typically how they do that kind of thing. So I'm going to define my variable as C, and C is going to equal the cost of the present. Okay, so you want to identify what that is. Okay, so anytime they address the cost, we know that that's C. Okay, and so that helps us with writing our equation. All right, so let's go ahead and look back at the problem. Cole's mom gave him this amount to buy a gift for his favorite teacher. This covered 3/5 of the cost. And I already know now the cost is C. And so I can sort of see an expression here. And so I'm going to go ahead and write that. So we have 3/5 of, meaning multiply, the cost, which is C. So instead of times, I can just put 3/5 C. Okay, and so his mom gave him $13.32, and that covered 3/5 of the cost. So they're saying the $13.32 was 3/5 of the cost. Okay, and so we can put equals $13.32. Okay, now we can go ahead and solve this problem. So I'm going to move it up to the top a little bit and maybe actually shrink it up some. And now we can zoom in. So now we're going to follow our normal procedures that we would do to solve for a variable. And so I see 3/5 times C. So we'll go ahead and divide 3/5 by both sides, but we know we don't do that with fractions. Instead, we multiply by the reciprocal. So I'm going to do that to both sides. And this will cancel out, and I'm left with C equals $13.32 times 5/3, which we know would look like that. So now I can go ahead and multiply straight across. So let's go ahead and do our numerator there with our money. Let me grab my calculator. So $13.32. Notice I'm still talking money as I go, so I don't lose track of that. So I have $66 is my numerator and 60 cents. Okay, we'll leave it at 66.6 for right now. Divided by 3. So let's go ahead and continue solving that. Divide by 3. And so $66.60 divided by 3 gets us $22, and it's money, so I'm going to represent it with the 20 cents all the way to the hundreds there. Okay, and so there we go. We have the present, okay, as our answer down here. So let's go ahead and put C equals $22.20, and here's where we'll answer the question. The present costs $22.20 for Hutch, of course. All right, next one. We have Nook Amusement Park charges $15 for admissions and 50 cents for each ride. I am noticing those hints, right? Like each means times, and can sometimes mean addition. So I'm just noticing as I read, but not taking it too seriously. Sky spent $27 total at the park. So total is going to be either our sum or the product. So something to keep in mind. Let's focus on our question because that identifies our variable. How many rides did she go on? So the question is how many rides. So it makes sense for me to use R as a variable for that. And so R will equal the number of rides. Okay, so now let's go ahead and figure out and translate this question into an equation. They charge $15 for admission, so that's a one-time thing, okay? Plus, there's 50 cents for each ride, and I know what a ride is. I identified that as variable R, so you can see I can actually plug it into my word problem here. So here's what we have. We have a one-time $15 plus a 50 cents times the ride for each ride, okay? And so we have a 0.50 R, okay? When I do that, okay, I end up using a total of $27 total, okay? And so the question is, how many rides did she go on to then end up at that $27, okay? And so now we can go ahead and solve for R. Same thing, I'm going to move it up a little bit higher here, and let's go ahead and zoom in and solve this problem. So we're going to do the reverse of PEMDAS now to solve for R. And so I'm going to ignore this positive 50 cents R for right now and just focus on this positive 15. So we're going to subtract 15 from both sides. When we do that, we create a zero pair, and we're left with 50 cents R equals 27 minus 15. We have a 2 in the ones place and a 1 in the tens place, so equals 12. And then we can go ahead and notice we have R times 50 cents. So we can go ahead and divide 0.50 from both sides, okay, which is really just cutting that in half. And so we have R equals, let's see, oh, it's divided by 0.5. 12 divided by 0.5 is different. That is going to give us 24. Okay, so that's 24 rides. So we have R equals 24 rides. And then we need to just make sure we have the label and answer the question. How many rides did she go on? So she went on 24 rides. So think and just make sure that makes sense. 50 cents a ride, 24 rides, and then plus we have that $15 initial fee. Okay. All right, moving on to number 3, Chloe. Here we go. Chloe's getting ready to move. To prepare, she had some boxes, which is interesting. Listen to that language. She had some boxes and bought 7 more. So a lot of times this can end up being your variable, but let's just go ahead and see. Bought 7 more, that sounds like adding 7 more. A lot of times and means add, but again, keep reading. The next day, half of her boxes blew away in a big windstorm. So half is a fraction. Half of the boxes typically means multiplication here. So let's keep going. There are now only 22 boxes left. So that's the sort of remaining total. How many boxes did she start with? So the question is how many boxes? Could be B for boxes, which also lets me know that my sum boxes is the variable there. But let's go ahead and define the variable. So B is going to equal the boxes started with. And let's go ahead and look at all of our hints now. So Chloe's getting ready to move. To prepare, she had some boxes. So that is going to be our variable. And then bought 7 more. So and, in this case, does mean add. The next day, so then this happened, 1/2 of her boxes blew away in a storm. And now there is, meaning our equals 22 boxes left. All right, so let's go ahead and take a look and put this together here. So in order, we have some boxes plus 7 more. And then after she did that, half of her boxes blew away. So that'd be times 1/2. So I can just say times 1/2 equals the 22 boxes. So we could write it like that. I could just put that entire B plus 7 over 2 if I wanted. There's a couple different ways you could write it. Okay, let me go ahead and shrink this up. And then we can go ahead and zoom in and solve it. Okay, alrighty. So here we go. The very first thing that we're going to do is go ahead and we can distribute the 1/2 to everything. Or if you remember, one of the other things, if you look at it like this, if we did write it divided by 2, remember that we actually need to get rid of the denominator first before taking care of the top. Okay, so again, you have a couple ways to do it. I could have distributed that, or I'll just get rid of the 2 right away. So this is what I'm going to go ahead and do here. Instead of the divided by 2, we'll go ahead and multiply 2 by both sides, on both sides. Okay, and that cancels that out, and we're left with B plus 7 equals 44. And now I can go ahead and subtract 7 from both sides, and we end up with our B equals 37. So let's go ahead and write our official answer. And so we have B equals 37 original boxes. And so our official answer, how many boxes did she start with? She started with 37 boxes. Okay. All right, number 4. Avery takes an Uber to get to school 3 days a week. So that's probably important information as we're reading it. Okay. The Uber driver takes him 11 miles to get to school. So he's doing the 11 miles 3 days a week. So I'm just sort of paying attention to what's going on as we go. He pays $3.50 for the car to pick him up. Okay, so that would happen each day also. And an additional fee for each mile. So there's our multiplication there. In 1 week, Avery pays $35.25. So that's the total in the week. Here's my variable. How much does the Uber driver charge for each mile? So this is a cost again. So I'm going to use C. So if we define the variable, C is charge for each mile. Okay. Now we can go ahead and interpret this word problem. So let's start to identify, since we do have repetition of the 3 days a week, this reminds me of our distributive type of word problems that we've dealt with before. So let's identify the thing that happens on one day. So the Uber drives 11 miles to get to school, and he pays $3.50 for the car to pick him up. Okay, so we also have this additional $3.50 that happens. Okay, and he has an additional fee for each mile, or an additional, they use a different word, but it's the same thing, additional charge. So this is my C here, okay? So there's an additional fee for each mile. He drives them 11 miles. And so next to my 11 is my additional fee. So it's really 11 times that additional fee or charge. So we have 11C plus 350. So let's sort of just slow down and think about this. Is this the thing that happens every day? He drives 11 miles and has a charge for each mile and pays a $3.50 charge. So this is 1 day. So I'm going to put that 1 day in parentheses because we have a repetition. Okay. If I could spell repeat correctly. So this is the repetition that happens, is the 3 days a week. And so really this is where we have our distributive, okay? So all that's happening 3 different times. And the total of that is the $35.25. So that's how we sort of talk through that word problem, okay? Let me move it up here and shrink it up a little bit, okay? And then we can go ahead and solve for the cost. Okay, let's go ahead and zoom in here. Okay, now, like we've done before, we can go ahead and distribute this first, and you could get the 33C plus that other amount, or you could just go ahead and divide both sides by 3 and then do the other. Since we did the dividing method up above, let's go ahead and do the distributing with this one. Okay, and so I'm going to distribute this one out, and I'm going to get my 33C plus 3 times 350 would be $9, and then 3 of the 50 cents would be another $1.50. So what, $10.50? Let's just double check that. 3 times 350, yep, $10.50. So we have plus 1050 equals 35.25. Okay, I'm going to go ahead and move this over so my algebra is lined up nicely. All right, and let's go ahead now and do reverse order of operations. So I'm going to ignore my variable term here and just address my plus $10.50. So when I do that, we'll do the inverse operation and subtract $10.50 from both sides. Okay, and we're left with 33C equals, and we'll do 35.25 minus 10.50, and we get $24.75. Okay, we need to go ahead and get rid of the 33 times the C, and we can do that by dividing 33 from both sides. And we're left with C equals 24.75 divided by 33 equals 0.75, and that's money. I can see my cost, my C there, and so that lets me know that C equals $0.75. Okay, and let's answer the question: how much does the Uber driver charge him for each mile? The Uber driver charges 75 cents per mile. Okay, all right. And if we look at that, it does make sense. 75 cents per mile times the 11, and then add the 350. So we're looking at like $11-ish plus the 350, and then times 3 days. So definitely makes sense. We have a small amount per mile. All right, and then the very last one. When Pineapple sells their iDAPs, they increase the price $50 from what it costs them to actually make the iDAP. One Pineapple store made $5,000 for selling 10 iDAPs in one day. So that's their total that they made. So you can see that's a really important number to identify. That's usually on the other side of our equal sign. How much does one iDAP cost to actually make? So we have cost again. We're wondering how much does that iDAP cost? So that'll be my C. So let's define our variable. C is going to be cost of one iDAP. Okay, and so let's go ahead and interpret our word problem now. When they sell their iDAPs, they increase the price $50 from its cost. So increasing a price just means adding $50 from the cost, and the cost is C. Okay, and so at this point I have C, and from is actually sort of a switch word. It's interesting because this is addition. But anyway, I mean, I could do 50 plus C or C plus 50. It doesn't matter. I'm going to do the cost and then increase it 50 from that cost, just to utilize that language correctly. One Pineapple store made $5,000 for selling 10 iDAPs in one day. Okay, so I identify this. This is sort of my situation for one iDAP. And then I notice that I have a repetition. I have not one iDAP, but 10. So when I have a repetition, this is actually my distributive looking expression. Okay, so I have the times 10. And when that happened, we had a total of $5,000. Okay, so again, I can right away go ahead and distribute this, or I could divide 10 from both sides right away. It's really up to you how you want to solve it. If you want to try whichever way you like, I'm going to go ahead and distribute this real quick and just get the 10C plus the 5 times 10 is the $500 equals $5,000. Okay, and then I can go ahead and work backwards from order of operations and subtract $500 from both sides. And we end up with 10C equals $4,500. And then at this point, I can divide both sides by C, or divide both sides by 10. And when we do that, we end up with C equals, and this is just moving the decimal place one spot, and we get $450. Okay, and so when we go ahead and write our answer, that means the cost to make an IDAP is $450, and we need to mark that as money and answer the question, how much does one IDAP cost to actually make? One IDAP costs $450 to make. And that's it. So you can see, don't get too discouraged with these. They're not entirely easy until you just do a lot of them and get used to them. So be patient with yourself. Give yourself some grace with this, and ask for help if you need. Ask to do some extra problems with the teacher or things like that, because the only way to get really good at them is to do a lot of them and start to recognize patterns and notice those hint words and things like that. All right, great job.